So thank you very much, first and foremost, to Civo team for inviting me to speak tonight. I hope that you can see my screen. One of the things I'd like to talk to you about tonight, in fact, let me just double check, is Open Policy Agent. And the second thing is how it's being utilized at enterprise, and what are the sort of problems that enterprise organizations, fintechs, are actually going through right now. So here's some firsthand experience. And hopefully it'll be interesting because OPA is a very interesting project, but it also underlines some of the major architectural problems that need to be solved when utilizing cloud native technologies in traditional landscapes. So without any further ado, in this abridged version, I will just give you a quick who am I. I'm an engineering director at American Express. I work out of Victoria normally, and I have a team of SREs, cloud engineers, and other practitioners who help to keep the lights on for internal frameworks in the organization. So it's an interesting role. We do a lot of observability, tracing, microservice architecture, things like Istio, Google Anthos, and other jazz like that. And more recently, I've started working on how do we make our systems work better together. And this is really great because as part of the Continuous Delivery Foundation, as an ambassador, and as part of the DevOps Institute, these things kind of all just click. And so I saw a real kind of intersection of interests with the open source work I do and with the stuff I'm doing for work. So I hope you'll find this interesting. And if there are any more questions, please ask at the end or reach out to me privately. I think you might have seen some links at the beginning. So every story needs a beginning. And this story starts for me with developer experience. DX is a real barometer at the moment of how sophisticated a tech organization it is. It really is the gold standard. When you think of good DX, you think of Heroku. They've been doing this for a decade. You think of other companies like HashiCorp, and you even think of things like the Civo CLI, which are really testaments to how we're thinking about developers as the core drivers for grassroots business adoption and championing. So as such, when I was asked to help improve the DX at American Express and at previous occupations, it became apparent that there has often in large scale organizations been a problem where you see a disjointed experience, and that experience often is less joy and more pain. And therefore, I decided that the best way to represent this is in a very scientific graph. And part of my background has also been working at startups. And this is typically how I would work in a startup. You join on day one, you have a bit of pain getting set up, but then eventually it's great, right? It's a joyful experience because you have things like a CI/CD process that just works and enables you to deploy out to a production environment very painlessly, right? And it's a lot of fun in a small org because if you see there's a problem in the dev experience, you can just fix that, right? Or someone can open a PR. So usually in the first week, you're up and running. However, contrary to that, in an enterprise organization, this is the DX experience typically. There's sort of an abandon all hope, ye who enter here, when you join an organization, and you'll find by sort of the first month or so, you're really struggling to get just a React package out to update a website. And this is really the crux of where I want to sort of explore in this brief talk. And, this is backed by actual empirical evidence as well as qualitative evidence. So I've used a Likert scale in a survey. And those of you who might have read Accelerate, which has authors such as Jez Humble on it, will know that these kind of psychometric tests can wean really interesting answers out of developers. Like, did you find this experience using Jenkins good, great, or amazing, or terrible? These kind of questions. And what these answers, when you start to aggregate them from a large developer community, is that often you'll find that the experience, the larger the organization, the more painful it is. And I think that just makes common sense anyway. But let's really ask the why of why that is. The why comes down to interoperability. And I've put a big Oxford Dictionary definition, which I found confusing when I was speaking over this last time. So I'm just going to tell you, interoperability is the ability of computer systems to exchange information or make use of it. Essentially, how well do things work together in a single organization? When we think about it in this example, let's talk about how does a product engineering team deploy a website? How do they deploy an API, a code change, right? That is essentially going to be the bar and the journey for our interoperability. And that's everything between the security, the compliance elements, the load balancers, the network ingress, all that jazz. How well does all of that work together? Well, I'll tell you, in enterprises, which are, completely predicated on conflict. Interoperability is in the negative because of the very nature that the culture is formed. And there's a problem with the strata of these businesses in that you have knowledge silos. And again, all of this stuff I'm saying probably doesn't sound like anything too profound, but when you start thinking about how this really impacts organizations that are moving in a cloud native direction, you start to see that it actually creates a schism and almost like a dam building up pressure behind it with people wanting to deploy, you start to get lots of conflicts internally. So I drew this very basic diagram, and I hope this sort of illustrates the basic camps you have at any large scale organization. Now, I'm not going to put names to this, but this is fairly representative of a basic setup where you have separation of concerns in terms of lines of business, but more distinctly, you have separation of concerns within technological organizational units. So CI/CD teams, SecOps teams, so on and so forth. This is an example of when you work at a large company, you would probably have to talk to all these various teams through some sort of ticketing system, an ITSM. Even if you want to deploy that React package, I bet you probably have to talk at the network ingress team at some point, or perhaps even someone running converged infrastructure. And these are little pockets of power who act as gatekeepers, and this is no good for anybody. So behind the scenes, what's actually going on here is that you have a lot of different processes that are happening to get to production, and a lot of different flows and concerns. And the philosophy behind enterprise interoperability is to reduce the complexity of these flows. So this is a relatively simple example, but you can already see there's a lot of arrows and a lot of boxes here, which essentially mean that there are things that need to happen in order for your package to get deployed out to the real world. And so as part of simplifying this topology, we need to create ubiquitous and commonly accessible APIs. And so Kubernetes, great, that's one piece of the problem solved, but it's not all the problem solved, because to exclude non-cloud native, so traditional services, mainframes, existing landscape is folly in a large-scale organization when you're trying to get buy-in. And so what we decided was the mission statement should be the following. We want the developer experience in an enterprise to feel like that in a startup. That was a really good mandate, because that gave us the idea of, how do we start to think about taking this huge problem that's like staring at the sun and breaking it down into something that's simple and can be itemized and attacked in different parallel activities. So when you think about your inventory of considerations here, you have to think about your existing ecosystem. You think about the services and systems, their varying levels of maturity, the security concerns that may overlap but are not always the same, right? You may have SecOps teams operating within several of the lines of business in a horizontal fashion, but you will also find security teams in an isolated silo, in a vertical fashion somewhere else in the business. So they don't always have the same, SVPs or whoever it might be they're reporting into, and therefore there's by nature competitive activity going on there. And so as part of moving to more of this startup model, we also want to change the culture at the same time. And believe it or not, I think you can do it if you introduce one of the CNCF's latest adopted projects, Open Policy Agent. So it's a bold statement to say you can do all this with OPA, but I'm going to talk to you about some of the activities we've started to put into place and some of the outcomes we're starting to see. But before I do all of that, I want to tell you what OPA is. So OPA is essentially a policy decision-making engine, and it reads files and it gives you an outcome, right? So the idea is that when your software needs a policy decision make, it queries OPA, right? It queries OPA, it supplies structured data like JSON as an input, and then OPA takes any sort of arbitrary structured data, and then it will give you an output, sort of a binary yes, no, this can proceed. I mentioned it's a CNCF project. It's incubating currently. There are a few different bets on, but OPA is extremely prominent because of the capabilities that are provided by DAS. I'll mention that a little later on, that allow an enterprise layer on top of this, but also because of the strong community and reusability around OPA. And I'll go into talk about what do I mean with all this a little bit now. So first and foremost, OPA is declarative. It has a policy-aware context. It's extremely fast. It's portable. So it's based on what's called a RAGO. A RAGO is a file type that was inspired by Datalog. And data log was essentially extended and restructured to support modern document models such as JSON. Rego queries are assertions on the data stored in OPA. And these queries can be used to define policies that enumerate instances of data that violate the expected state of the system. And so in my very simple Silicon Valley reference, which is actually straight from the Rego playground, you can see how this might work, right? This is a function-like block of code. It says, okay, well, if there's a certain label or there's a certain, in fact, there's a variable defined image, which is based off the YAML spec of the admitted object. If that starts with huli.com, don't allow it. In fact, it's the inverse. If it doesn't start with huli.com, don't allow it. And so this is already game changing, because you're suddenly thinking, wow, as a security engineer, I don't have to tear my hair out trying to build some custom Jenkins Groovy library thing that scans images when they get deployed. So at the outset, it's extremely interesting. The second thing that's really awesome is that there's a first-class integration with Kubernetes called Gatekeeper. The thing is, OPA is not explicitly built for Kubernetes, but Gatekeeper enables it. OPA can be combined with Envoy, and that's exciting as well, because by combining OPA with Envoy, you can do some very cool stuff. Now, when it was combined with Gatekeeper in this integration, you got a couple of things out of the box. You got the ability to have CRDs for OPA, so you've got constraint templates. And I'm going to go into what all this means, but essentially you can templatize your library and you can share these around, right? So one engineering team is using a particular set of constraints. You can do a kube control apply on your local machine. If you've got OPA running, a kube control apply in your namespace, if you're running in a dev environment, and replicate some of those wanted constraints. You could be a developer doing it. You could be a SecOps engineer doing it. You could be the SRE or the cluster operator, making sure that that cluster is always running the huli.com check, right? Now, back to what I was saying about Envoy, OPA also supports WASM. So if you're not familiar with WASM, it's WebAssembly binary instruction format, which is a stack-based virtual machine format, which is developed sort of C++, C, Rust, and all those sort of languages that enable you to deploy on the web for client-server applications. And this is super exciting, and it's very new because WASM filtering in Envoy with OPA enables you to do super low latency and low cost checks. That is interesting because it means that you can call it from a web client. And here I'm just showing a little excerpt from Vue.js where somebody is actually initializing a Rego and then actually serving it. So there's an interesting future there. And finally, as I mentioned earlier, DAS, so Declarative Authorization Service, is the enterprise ready and sort of the supported way of how you can scale this out with a visual GUI. You've also got the ability to codify repositories of policies and share them around. And so from an enterprise perspective, it's extremely exciting because you've got something with support, you've got something with a flashy UI, and everybody loves a flashy UI if you're an executive. So all that said, and all those great things I've said about OPA, I'm going to just do a micro demo. And it's a micro demo because it essentially comprises of me doing a couple of very basic things. So please shout if you cannot see my terminal, or I'll keep going. Yep. Okay. So I've really boomed it up here so you can see it really simply. So first and foremost, we've done a little grep here, and we can see the out-of-the-box custom resource definitions. So these are extensions to the Kubernetes API that you get out of the box with OPA. So OPA-Gatekeeper, I should be more precise. Here you see, as I said, you've got this idea of a constraint template, constraint pod status, etc. So let's actually look at what is a constraint template. Well, we go to our Kate's label constraint template, and I'm not going to walk through this entire file, but I will show you the interesting bits at the bottom. I've got a very obnoxious colored Vim background. I don't know why this is, but it's quite suitable for this talk. So as you can see here, the Rego actually targets the package, and then it has an implementation of the policy. So this is the violation, a bit like I was showing in the first slide, and you can create this as something that is callable as a template. So that sounds a little vague. So what I mean by that is I can create this Kate's constraint label constraint template, And then as a cluster administrator, let's say that out of the box, my cluster ships with all these constraint templates, but I might want to turn them off or on. And this might be familiar to people who use OpenShift, because OpenShift has a very similar kind of governance methodology that's just been applied to it. Well, let's pick one for namespaces. So what I'm going to do is I'm going to use the label of gatekeeper, and I'm going to say that it's using the Kate's required labels kind. And this is important because that matches the template policy that I have. And what I'm going to do now is I'm going to take that namespace. In fact, before I do that, let me just show you. I go Q-control create ns whatever temp1, right? Shouldn't have any problems. Now let's apply that namespace constraint. And what we should see here is that once that applied, I can go and run a cool. Let's create something else. So we'll go Q-control create ns temp2. Oh, and it says, oh, you've got to provide a label. So what we can see is that policy requiring the parameter of label is now part of the object admission check. Now let's just go back and understand what actually happened there. So if I open the Kate's file again here, you'll see that in the violation, it requires label to be provided, and label has to match in this YAML file of parameters. So if that label doesn't exist on the admitted object, then it's going to kick up a fuss. So that's the 10-second demo there, or 2-minute demo, that hopefully shows you some of the power, because instantly it's blocking any new object admissions. Now, I'm talking about object admissions. Let's dig into why this is interesting, what an object admission is, and where this goes from here. But first, let's just identify that, OPA is really helping us to create a new type of self-service experience. As an engineer now, I am dictating what's going into a cluster, which usually used to be the exclusive right of somebody who had RBAC permissions in that cluster. I can now control, if it's been delegated to me, what I can have go into my namespace. I can run my own microservice architecture in a tenanted cluster in my own namespace and say, okay, well, you folks can do this, but you can't, and you people can do this, and be way more high fidelity than RBAC is on its own. So a whistle-stop tour of how this works, just conscious of time, is that you have an object submission. That object submission is when you would do and sort of create some YAML and post it to the Kate's API server. OPA Gatekeeper hooks in at the admission review phase. So in that pre-creation phase, the policy will be challenged, and that challenge will do a check and then give an admission response. And then that will go downstream to the controllers, right? And then in our case, we can start thinking about, well, what if the controller isn't just a create pod or a deployment manager? What if that controller is a custom resource definition controller, and we can do some other things? That's when things start to get really interesting. And that's when we start to be able to think about solving some of these enterprise problems. Because what we can start to do is say, well, I've got this ability to suddenly set very high fidelity policies. I've got this ability to create CRDs. I've had that for ages. I can express what I want to do. And I also have this now newfound trust that when an object is created and given to the operator, it's already gone through all the authentication and authorization and back-end checks. So the operator can just perform the reconcile loop. What that means in plain English is the following. You have the ability for this new model of a bring your own service, where people not in the Kubernetes club can start bringing their services into a Kate's environment by writing their own operator. So the kind of analogy I would give here is that if you run a mainframe or you run a big IP F5 load balancer in a physical data center, those things aren't necessarily just going to have a Kate's operator you can plug and play, or have an underlying controller that's applicable for them. However, now what you can do is write your own Kubernetes operator using KubeBuilder or something. You can integrate with your old-fashioned API. It might take 2 requests a minute, but your operator inside your cluster can control that. And then you can allow your tenants within the cluster to start saying, hey, I want to provision one of those. So that's a lot of stuff to think about. I'm going to show you it and break that down, what I really mean by that. So let's think about F5, right? So an F5 is a form of virtual IP, right? So a VIP. This is a super hypothetical example YAML file, but is the kind of thing I'd expect to see. So you would have the desire to set a host name. I've put a domain name, but it's academic vernacular, TLS termination, etc. And you've got a target for the internal cluster service endpoint. So hypothetically, this YAML could mean something like, I want to provision a VIP within the corporate network that will route to my cluster, and the CNAME is going to be set for this domain. There's a lot of information here. Now, I could just go off and create my service operator, and just provision a VIP and then come back again. But the problem here is that, there's a bunch of stuff that I haven't validated. And also there's a level of due diligence that hasn't been run, right? Cost center. I know it sounds petty, but everything has to be traced back to cost, especially in large financial organizations. Being able to check that cost center as part of the policy, if it exists, and if you have the authorization, is super important. Being able to take the current service account user, run that user against an Active Directory backend, and check if that user has permission is also important. And these are the start of things that we're able to answer with OPA. And as complex as that sounds, if you get that bit right, you can just federate that out, and people can start creating different types of service operators using the same labels and using the same annotations, and enabling people to bring Lego bricks into the cluster from their services that are outside of the Cloud Native Cool Club. So let's think about what really enables that. Well, that's because OPA supports two things. It supports plugins. It's written in Golang, so it supports plugins, but it also supports extension of the built-in functions. Extension of the built-in functions enables some super interesting stuff. So Active Directory data management is centralized because you need to have strong consistency, flexibility, and verification. But in here, we're enabling policy enforcement to be done through OPA, through our distributed Kubernetes clusters. You could have 2 tenant clusters, you could have 100,000 tenant clusters, it doesn't matter. But this ensures you have super low latency, high availability, and strong policy enforcement. Any data changes in Active Directory, in this little example, will be published and distributed to the OPA instances dynamically. Now, in this example, again, this is a pull sort of style where somebody runs a object ignition, the OPA agent runs a function, that function does a post request, does a get, checks something, but you could easily do it in some more sophisticated method. When all these things come together, the extensions, the policy, the operator, you get this kind of system. And let me talk you through it. So remember that diagram right back at the beginning, that little illustration of the complex Disney castle and the different forts. You have something that looks a lot more like this. It's a sequence. It's like a sort of a car production line now, in that you have your CRD. This might be saying, hey, we're an engineering team. We've had something in dev. We want to promote it to the next environment and get an ingress for it. You create a CRD for that. You look up on whatever it is, Confluence or other godforsaken CMS, and you say, okay, right, this is how the notes say to do it. That's great. You then commit that in. Hopefully you'd have a GitOps process that would then pull that into your cluster. OPA would then go through the admission phase. Now, in this example, we have two groups who are interested. We have cloud provisioning policies, which comes from our private cloud team and SecOps, and we have business intelligence who want to make sure that I've got the right labels on my workloads. And here, again, as I mentioned previously, what would happen is the cloud provisioning policy would be based on the fact that you have packages for the cloud provisioning module and the ADS module. So what I mean by this is, let's take an example. If I request not an F5, but if I request that when I create this CRD, I can have access to, let's say, additional ports on the node if they're locked down. And the cloud provisioning module team would go off and check your ADS. They'd also check that that request had been fulfilled. And what you start to see here is that naturally there's a reuse, right? Because the cloud team have got that module. So next time down the road, the CI/CD DevOps team might also want to leverage that. And this is where it's great, because there's reusability everywhere, right? You can do it at the Golang level, at the modules and extensions of the functions. You can do it at the policy level, and you can even do it at the service operator level if you have very many similar services. So we found that there are sort of 3 key benefits, and there are 3 key observations that we made. So benefit and observation is that high performers, companies in general, have high interoperability. This is, it sounds obvious, and it's the inverse of the graph I was showing you earlier on, but more joy is generated when you have high interoperability, because it usually denotes there's higher automation within an organization. The second part is that Open Policy Agent integrates into developer workflows and provides simplicity and reusability. This was something that actually started to gain traction after implementation, not during or before. And the reason being is that it takes a bit of time to create an ecosystem. And what happens is you start to garner a bit of a grassroots approach where engineers will say, okay, well, do you have a policy for this? Or who is it that's making me enforce this? Why do I have to have this when I create my template? And then you start to see that they become hubs of activity where you'll get repos that are gravitated towards, or people want to contribute to, so that policies are shared and understood. It also is a godsend for SecOps teams who are, trying to understand things, complex behaviors such as the way that Istio works, or Linkerd or other service mesh, are now able to actually take all of that and underline it with a simple policy matrix. And so therefore, I've seen people are really championing this as a way of really reducing the overhead involved when making policy decisions on an individual service. Because if a service automatically adheres to policy decisions by running OPA test on their local, and they can pass all the policies of their service, it makes those teams feel a lot more confident before they deploy them out. And thirdly, cluster policy engines can controls service access, enabling self-service. And this is just really, again, to hit home on the previous point, that once you have this in place, you can start enabling people to bring their own operators to the table, from the mainframe team, from the F5 load balancer team, from the converged infrastructure underlying storage team, to say that here is what we want to bring, here's our policy, here is our service operator, and here's our CIDs. This is how we want people to use it. This is how we're going to manage it. And again, just to segue slightly, there is another benefit here in that these teams are gaining vital Golang Kubernetes experience and being brought into that cloud ecosystem as well. So you're really aligning the whole technology organization on this sort of pathway together to start to bring all of your technological services together. So very quickly, lessons learned. Well, lessons learned is that you can't go big bang on this. People like to make small bets, especially with new technologies, and therefore you need to go very narrow but very deep. So have one use case that works really well. This idea of taking an F5 or a Cassandra node, like having a Cassandra cluster that you can just spin up, even though it might belong to some other team. That's a great example, or Kafka or something like that. We learned that this is still a work in progress. It's got 1 million miles to go, but the things that are going to be really key to succeeding are the developer feedback sort of notes on how they're getting on with this and how they're enjoying interacting with this, but also how is it starting to change the internal culture, and how is it starting to put DX in the driving seat. Finally, if you'd like to learn more, I've written a bunch of articles on this. It's a complex subject. It's interesting. Interoperability in technology organizations is a big thing right now, and it's a problem and a sort of a mountain that many people are trying to climb in different ways. So there's no means a set menu on this. So let's see where it goes. And by all means, please reach out. And that's me done. Thank you.